Hello, this is Kate. This is 2020 November SL. All right, paper 1, section B. Section A, in case you missed it, is in the description. So section B, first question, question 8. The median is 4. Well, we know that because this line is the median. Box and whisker. Interquartile range 1.1. So we know interquartile range is upper quartile minus lower quartile. So the 4.5 is the upper quartile. A is the lower quartile. So that's how you do part A. 4.5 minus A should give you 1.1. So this is paper 1, non-cal. So do a little bit of mental math. A should be 3.4. Okay, so there's a formula that change kilometer to miles. They basically want you to use this as a constant change to data. This is also in the new syllabus. So, for example, the median is 4 in miles. So if you want it to change it to kilometer, you just multiply by 8 over 5. So it's 8 over 5 times 4. So it's 32 over 5. The variance is given to be 16 over 9. Find the standard deviation in miles, okay? Notice this 16 over 4 is in kilometers square. So we know standard deviation, well, at least you should know the standard deviation is the square root of the variance. So it's root 16 over 9 kilometer square. So if you root that, it's 4 over 3. Technically, you root the kilometer square as well, so it becomes kilometer. Then you want to change it to mile. So if kilometer equals to 8 over 5 miles, then you multiply the 5 to that side, and then divide the 8. Then to change from kilometer to miles, you multiply by 5 over 8. So cancel a bit, so that gives 5 over 6. Okay. Okay, that is not the end of the question. This part is rather easy, but the coming two parts are not. Okay, so there are 600 people running this race, and the following is the cumulative frequency graph. So we see that 400 of them needed 22 to m minutes to finish this race. Question is, what's m? Okay. So 22 is like here. So we go up to here. If you read the graph, this is 20 people. So there's 20 people that took less than 22 minutes. Now we want to find out people that are between 22 to m, but the question actually told you that there are 400 people that took 22 to m. So from 22 is 20, you add 400, you go to 420. Okay, because this range would contain 400 people, so that must be the top. So if you cut down here, you get 30. Okay, so m is 30. Okay, last part is E. The fastest 150 people would win a prize given that someone took 22 to m minutes. Find the probability that he won a prize. Okay, in case this word given didn't ring a bell for you, well, I should tell you, the given means this is conditional probability. To do conditional probability, you need to use the conditional probability formula. So if you go to the formula, it says the probability of A given B is the probability of A intersect B over the probability of the given thing. Okay. So A is what they're looking for, B is the given thing. So this time, the A is the probability that they won a prize, okay? That's what they're asking for, so the probability of winning a prize. Given that he took 22 to n minutes. So it's between 22 to n minutes. Over the probability that he took between 22 to n minutes. Over the given thing. I'll make this mistake. Just like this. Okay. Because I'm already using the formula. Okay. Okay, it shouldn't be too hard to get the bottom. The bottom is, well, if you randomly pick someone, what is the probability that he took between 22 to n minutes? Well, the answer is there are 400 that took that time over a total of 600 of them. Okay? But the hard part is the top. What is the probability that someone wins a prize, and remember intersect means and he took between 22 to n minutes. Okay? Now hint is you're gonna need to read the cumulative frequency polygon. If you want to give this problem a try, like say you're aiming for 7, you really should. Then pause the video now. Answer becoming 3, 2, 1. Now you actually need to look for the number of people that both won the prize and took between 22 to n minutes. Okay? And the first 150 people would won the prize. So what that means is the first 150 people, so these are the first 150 people, they won the prize. Okay? And if you remember, this red range, this 20 to the 420 people are the people that took between 22 to n minutes. So the number of people that both won the prize and took 22 to n minutes are the people in between. Okay? So it's from 20 to 150. So basically, there are 130 of them. So the probability of finding someone that both won the prize and took 22 to n minutes is 130 over 600. Okay? That's how you do this conditional probability. Okay, so you really should know how to should learn how to simplify this kind of fraction. The bigger fraction I mean is divide. So this is 130 over 600 divided by 400 over 600. To divide a fraction, you multiply and flip, and so the 600 cancel out. So the 0 also cancel out. So the answer is 13 over 40. Okay. So although this is only the first question of section B, part E is not easy at all. Now the next question is a completely vector question. So I think I've mentioned it in the last video. Vector is no longer inside the syllabus of AASL. Therefore, I will skip this. Okay, we are finally at question 10. I think I said it in the section A video. This question is crazy. It's marginally, but it could be the hardest SL question I've ever seen. And it's not only the math is kind of difficult, and it's really difficult to guess that they want you to do what you see me do. Okay, that's the hard part. It's very unpredictable. It's so unexpected. The fact that we're gonna do what we're gonna do. Okay, now part A and B are actually like kind of reasonable. It's on the difficult side, but it's still reasonably difficult. It's just doing differentiation with a lot of unknowns. Okay, so the function contains k, which is an unknown. Obviously, it contains x, like that's nothing new, but they have a k to represent a constant. The touching point is also an unknown, and they work everything with those two unknowns, the k and the p. That itself is quite hard, okay, but it's still reasonable, I think. So the crazy part is this part, but let's not go too much ahead of ourselves. We will do part AI first. They want us to find the derivative, so we will find the derivative, so fx. So you probably know to differentiate k over x, you need to change it to a power. So it's k times x to the power of minus 1. That's because 1 over x itself is the same as x to the power of minus 1. And k over x is the same as k times 1 over x. So we differentiate. Remember, when you differentiate, the number in front of x stay there, don't do anything. So this k actually just stay there and don't do anything. And you differentiate, you drop the power, x, and then you minus 1 from the power. Minus 1 is minus 2. So this is the derivative, and then you sub in p, because p is the touching point, okay? So it makes sense to sub in the touching point, except they use an unknown to represent the touching point. And remember, differentiation means gradient, so the gradient is this value. The gradient is negative k over p squared. Again, that's because negative power means 1 over. Okay. So yeah, probably even AI is challenging to some students. And yeah. But let's hang in there with me. Find the equation of the tangent line. L1 is a tangent. So to find the equation of a straight line, I usually do mx plus c. And we know m is the gradient. And we also know differentiation gives you gradient. So this is exactly the gradient. So it's minus k over p x plus c. To find c, you plug in a point on the line. So you can use the touching point. So the touching point is p and k over p. So y is k over p and x is p. Okay. Yeah, from the last, these 2 years, IB really like to test this kind of algebraic ability in Excel. The fact that all the numbers are represented by a letter. So the p and p squared cancel out. One of the p cancel out. So if you are aiming for 7 for SL, you really need this ability. So you add this to the other side. So you have k over p plus k over p. If you have the same thing, equal. This is equal. If you have the same thing at itself, that's 2 times of that. Okay? So c is 2k over p. Let's go to the side. Therefore, the equation of straight line, the equation of the tangent, is minus k over p squared x plus c. You just put the c back in there. It's 2k over p. Okay, but then you want the line to be in this form. That simply means you don't want any denominator. So you multiply both sides by p squared. So it becomes p squared y equals to, when you multiply this by p squared, it cancels out the p squared in the bottom. So it's minus kx plus, if you multiply this by p squared, it cancels out one of the p. So there is still one more p. So it's 2pk. And then you add everything to the left. So you move this to the left, it's kx plus p squared y. And then you move this to the left, it's minus 2pk equal to 0. Okay? So this is already not easy. I keep saying that. So take your time. Then puppy is not too bad. The line intersects the x-axis at a point 2p, so they gave you the x-intercept of the tangent line. Okay, and they cut the y-axis at b, so that's b question, find the area of the triangle. Okay, so just one area of this. Okay. It's a triangle, so we can just do base times height divided by 2. So find the length of the base times the length of the height. Some of my students, when trying this, actually thought of doing integration. It's actually possible. You can go back to the equation of the tangent line. Well, it's not this one, because we need to see. You go back to this one. And then technically you can integrate that. From 0 to 2p. Okay. Technically that is doable. That would work. But I think that's a bit difficult, a bit too difficult. So I personally would recommend just doing base times height divided by 2 whenever it is just a triangle. A few years ago, there was actually a past paper that they made the calculation so difficult that if you use integration, it's doable, but it's gonna take forever. However, if you just do base times height divided by 2, it's way simpler. Okay, so keep in mind that I personally think IB also prefer base times height divided by 2 whenever it is just a triangle, or sometimes if it's a trapezium. So you can imagine if you have a line like this and you find the area in between like this, then this is just a trapezium. Then it is also preferred to do upper base plus lower base times height divided by 2. Okay, that's my personal opinion. So let's do that. So in order to find the height, we need to find the coordinate of B, but B is simply the y-intercept of the tangent line. The y-intercept of a line that look like this, y equal to mx plus c, is simply the c. Okay? So B have coordinate 2k over p. So the height here must also be 2k over p. Therefore, the area is base is 2p times the height divided by 2. So the p and p cancel out. So when you multiply the top, it's 4k over 2, so it's 2k. So the area of this triangle is 2k, okay? Somehow that's 5 marks. It's true, this is all you do for 5 marks. Okay, here's the crazy part. First, let's read the question. First of all, the whole graph is translated to the right by 4 and up by 3. Okay, so everything got translated. Okay, that basically means this is 4 and this go up to 3, so this is 3. Okay, and then what? Q is a point on G. Okay, so if you can see through the smoke, the Q is actually this P. Okay, they're the same. And L2 is a tangent at Q. Okay, since Q is actually just P, L2 is actually just L1. Okay, I actually have no idea why they need to rename everything. Okay, and then due to the translation, the asymptotes are also translated. So this is the original vertical asymptote. This is the original horizontal asymptote. Nothing special. Then all of a sudden they would say that the triangle EDF, so that's here, and the rectangle CDFG, so that's here, have the same area. Okay? They have the same area. But what's the question? Well, they want to find the gradient of L2. Like on the surface of just the question, why would the area of the triangle and rectangle be related to the gradient of L2? So, I don't know, maybe I'm not that smart. This is quite ridiculous a question. Okay? But if you realize that this L2 line is basically this L1 line, okay, then you realize that this triangle is basically this triangle. Okay, they even try to draw it in a different proportion to lie to us, okay? And we found the area of that triangle is 2K. So what that means is this triangle also have area 2K, okay? This area is 2K. But the area of the rectangle is the same as the area of the triangle, so the area of the bottom rectangle is also 2K. Okay. And then we know this. I said this is 3, so this DC is also 3. They're the same, right? And then what about this CG, okay? This CG is actually the same as this DF, right? But this DF was actually the base of our triangle. The base of our triangle actually had the length of 2p, right? We did that here, 2p. So this length is actually 2p. Okay? I hope you can follow me just now. Rewatch if you have to. Okay, the key is now if you figure out the height of the rectangle and the width of the rectangle, then you know how to find the area of the rectangle. The area of a rectangle is width times height. But we also know that area has to be 2K because it has to be the same area as the triangle. So somehow we realize that 6p equals to 2K. That means K is 3p. Okay, so K is 3p. How is that related to the gradient of L2? Well, the answer is L2 is actually L1, and L1 has a gradient of this, of negative K over p squared. Okay, remember mx plus c, the m is the gradient. And of course, that's also the answer to part AI, which is the answer to the derivative at p, which of course also mean gradient. So the gradient of L2 from previous is actually negative k over p squared. Well, they want the gradient to be in terms of p only. What that means is you don't want k. Well, but look at what we just found. We know that k is 3p. No, there's no 3 in the bottom. K is 3p. So the p cancel out. Now we found the gradient of L2 in terms of p only. Alright, so it's not like you need to do some crazy difficult math, but the level of thinking that you need, and they are not like deep, reasonable, logical steps that you take, okay? They're like random facts that you gather from everywhere, then you would magically be able to do this. So again, if you have watched my previous video, I have said it over and over, SL has been getting quite hard. Now, but one thing we're not sure is we don't know if the trend gonna be continue to AASL. So we don't know if they still gonna make it harder. Well, I hope not. But judging from this question, I think we need to prepare for the worst. Okay, so this is the end for paper 1, and hope I'll see you in paper 2.